Hi students, welcome back to this course, An Introduction to Mechanical Engineering. I am Professor Yao. Heat as energy in transit. Transfer of heat. The key words. Transfer of heat. Because of a temperature difference. 3 mechanisms for heat transfer. Conduction, convection, and radiation. Current, voltage. Fourier's law of heat conduction. Thermal conductivity. Fiberglass. Convection. Forced convection. The buoyancy force. Transfer of heat. We have described heat as energy that is being transferred from one location to another because of a temperature difference. The 3 mechanisms for heat transfer are known as conduction, convection, and radiation. They arise in different mechanical engineering technologies. When you grip the hot handle of a pen on a stove, you feel conduction in action. Heat flows from the pen and along the length of the handle to its cool free end. One end of the rod is held at high temperature, T sub H, and the other end stays at the lower temperature, T sub L. Although the rod itself doesn't move, heat flows down it like a current because points along the rod have different temperatures. Just as the change in voltage produces a current in an electric circuit, the change in temperature T sub H subtract T sub L causes heat to be conducted along the rod. The quantity of heat that flows along the rod during a time interval delta T is given by equation 7.8. This principle is known as Fourier's law of heat conduction. Heat conduction occurs in proportion to the cross-sectional area A, and it is inversely proportional to the rod length L. Thermal conductivity, the material property K, the lowercase Greek character kappa, is called the thermal conductivity. When the thermal conductivity is large, heat flows through the material quickly. Metals generally have large value of kappa, and insulators, such as fiberglass, have low values. Convection. In addition to conduction, heat can also transfer by a fluid. Fluid head is in motion. That process is known as convection. The cooling systems of automobile engine, for instance, operates by pumping a mixture of water and antifreeze through passageways inside the engine block. Excess heat is removed from the engine, transferred temporarily to the coolant by convection, then ultimately released into the air by the vehicle's radiator. Forced convection. Because a pump causes the coolant to circulate, heat transfer is said to occur by forced convection. In other circumstances, a liquid or gas can circulate on its own, without a pump, a fan being present. Because of the buoyancy force created by temperature variations within the fluid. As air is heated, it becomes less dense, and the buoyancy force causes it to rise and circulate. Natural convection. The rising flow of warm fluid and the falling flow of cooler fluid to fill its place is called natural convection. In fact, many aspects of the Earth's climate, oceans, and the molten core are related to natural convection. Radiation. The third mechanism of heat transfer is called radiation. This term refers to the characteristics that heat is emitted and absorbed without direct physical contact, and it is unrelated to radiation in the context of nuclear process or power generation. Radiation occurs when heat is transmitted by the long infrared waves of the electromagnetic spectrum. Those waves are able to propagate through air and even though the vacuum of space. Energy from the sun reaches the earth through the process of radiation. As the electromagnetic waves are absorbed by air, land, water, they are converted to heat. The radiation in a house, in a home heating systems, comprise winding metal pipe through which steam or hot water circulate. If you place your hand directly on the radiator, you feel heat flow directly into your hand by conduction. However, even if you stand some distance away and do not touch the radiator, you are still warmed by it through the process of radiation. Homework. Handwriting all keywords and submitting them to Coach Facebook. Just do the online quiz and see you next time.